A two-terminal linear network is given. The two terminals are A and B, and when a resistance R of 10 kilo ohms is connected to this terminal, the measured voltage across AB, VAB, is 6 volts. And when the value of the resistance is 30 kilo ohms, the voltage AB is 12 volts. So we have been given these two information. Now we need to find the Thevenin's equivalent of this network. So in order to do that, let's assume the Thevenin's network like this. So we have a Thevenin's voltage, V Thevenin's, and we have a Thevenin's resistance, R Thevenin. So, and let's assume this R, which is connected here, the value of R is when 10 kilo ohms, the voltage here, this is terminal A, this is B, so the voltage VAB is 6 volts, and when this is 30 kilo ohms, the voltage is 12 volts. So the voltage VAB is, if we just write the equation, is actually just we can get from voltage divider rule using. So this voltage is getting divided between these two resistances, R Thevenin and V Thevenin. So VAB will be V Thevenin over R plus R Thevenin times R. This is the equation, the voltage divider rule. So we have two conditions. We have when 10 kilo ohms 6 volts and when 30 kilo ohms 12 volts, and there are two unknowns, so we should be able to solve it. So let's do that. When VAB is 6 volts, the resistance is V Thevenin here. The value of the resistance is 10 kilo ohms plus R Thevenin, which we don't know, times 10. So this is 60 plus 6 R Thevenin is equal to 10 V Thevenin. So this is one equation. The other one will be 12 when the voltage is 12 volts, V Thevenin, R is now 30 plus R Thevenin, and this one is times 30. So this is equation 1, let's say, and this equation becomes 360 plus 12 R Thevenin is equal to 30 V Thevenin. So this is equation 2. So we have these two equations. So what we can do, we can multiply equation 1 by 2, and then so I will write it other way around. So 2 minus 1 times 2. So equation 2 is 30 V Thevenin is equal to 360 plus 12 R Thevenin, and when 1 is multiplied by 2, it becomes, I'm writing the right hand side first, on the left hand side now I'm writing, so this is getting multiplied by 2, so it is becoming 20 V Thevenin, and this will be 12 R Thevenin and 120. So 120 plus 12 R Thevenin. So I'm just trying to get rid of R Thevenin, and I'm subtracting now. So this will be 10 V Thevenin and this will be 240. So V Thevenin's will be 24 volts. So we are getting V Thevenin. And then we can get R Thevenin as well from the equations. So maybe I will use the first one. So 60 plus 6 V Thevenin, R Thevenin is equal to 10 V Thevenin. So 10 V Thevenin we have. So basically 6 R Thevenin is 10 times 24 minus 60, so that is 240 minus 60, so that's 180. 6 R Thevenin is 180, so R Thevenin is of course 30, and it will be kilo ohms because the resistance is kilo ohms. The other resistances are in kilo ohms, so that's the R Thevenin. So we have the Thevenin's equivalent circuit. Now V Thevenin's is 24 volts and R Thevenin is 30 kilo ohms. So basically any two port network can be, the Thevenin's equivalent of that can be found just by measuring the output voltage by two different resistances, and we have the voltage divider rule. There are two unknowns, and with these two measurements we will get two equations, so that will be, it's enough to solve them.